I did want to do one question where I sort of put everything together because I know, especially when you're learning this for the first time, it's maybe hard to keep everything straight. So I did want to do one question where I go through every part of it with you. I'm going to have to be very creative in my space here. So I'm going to start with how I would typically start a question like this. And how I would start a question like this is I would go ahead and find the first derivative, because as I can see, I'm finding critical numbers, which uses the first derivative, intervals of increase and decrease, which uses the first derivative, and E, minimum and maximum, which uses the first derivative. So I'm going to use the first derivative for everything I've underlined or circled in purple. And the first derivative is 3x squared minus 4x. And for the sake of, the fact that I know I'm going to use it, I'm going to go ahead and find those critical values. So I'm going to find 0 equals, actually let's go ahead and factor this. Take an x out, get 3x minus 4, which means x must be 0 or 4/3. So for A, question A, I'm just going to put these over here. For A, the critical numbers are, actually let's not do that because that might get confusing. For A, the critical numbers, and it's best to label everything because it's really easy when I'm grading your work to not figure out what it is that you're doing, so make sure you label. My critical numbers are x equals 0 and x equals 4/3. So that's what I've done so far. For B, I want the intervals of increase or decrease, so find those intervals. So again, I'm just going to make a table. So I'm going to make a table down here. I'm going to use the points of 0 and 4/3 to come up with those intervals. And I'm just going to make the short version of the table, which is I'm only going to put the intervals and then plus or minus, because again, for the sake of time. So remember, when I'm doing this one, which is where I'm finding the intervals of increase, decrease, I'm plugging it back in to my original, or to my derivative function, my first derivative. So take a point like, say, -1, that's in my first interval. I get 3 times essentially 1, so 3 minus -4, this is a positive value. Plug in a point like +1, and I get a negative value because I would get 3 minus 4. Plug in a point like 2, and I would get 3 times 4, that's 12 minus 8, which is 4, which is positive. So for B, intervals of increase, decrease, I would say it's increasing from -infinity to 0, union, 4/3 to infinity, and it's decreasing from 0 to 4/3. So far so good. I'm done with A, I'm done with B. I'll go back to E at the very end. I'll make sure I save room for it down here. Let's go ahead and pop over to the second derivative. So again, this is what I did second. The second derivative will help me to determine intervals of concavity and points of inflection. That was weird that it changed color in the middle. Points of inflection, still the wrong color. Good God, please help me out. So I'm going to go ahead then and find the second derivative. So f double prime of x is equal to 6x minus 4. And then of course I'm going to go ahead and find where that is equal to 0 or undefined. And here it is not ever undefined, but I would get 4 equals 6x, and then, oops, not 3/2, 2/3 is equal to x. So remember, I'm trying to find C, which is intervals of concavity. To find intervals, I got to make my table just like I did before. So I'm going to make a table. I don't need it to be that big because I only have one guy. -infinity to 2/3, 2/3 to infinity. I'm going to plug in a value like 0. Again, into the second derivative, if I plug in 0, I get 0 minus 4 is -4. If I plug in a number like 1, I get 6 minus 4, which is 2, which is positive. So I've now found my intervals of concavity. So that's C. Intervals of concavity would be concave up from 2/3 to infinity, and concave down from negative infinity to 2/3. So that leaves me with D and E. D tells me I want that point of inflection, but I want it as a point. And then E, I want the min or max, or both, and again as a point. So how am I going to do that? Again, we didn't really do much of this in our previous examples, but let's look at D first. We know that if this goes from concave down to concave up, that this point in the middle, 2/3, is a point of inflection. So whenever I get something like this, where it says find it as a coordinate, I'm just taking that value of x and plugging it back into the original equation. So 2/3 cubed minus 2 times 2/3 squared. 2/3 cubed would be 8 over 27. 2/3 squared would be 4 over 9, but doubled, so 8 over 9. And then, of course, I want to combine those together, so I'm going to take this times 3. Oops, I had 3 on the brain. Take this times 3 and take this times 3. So 8 minus 24 is negative 16/27. And so for answer D, my point of inflection is the point 2/3, comma, negative 16/27. For my very, very last answer, E, min and max as coordinates, I of course want to look at the values here because obviously, oops, wrong direction. Increasing to decreasing means that's a max, and decreasing to increasing means that's a min. But really I'm just taking the point of 0 and of 4/3 and I'm plugging those in as well. So f of 0 would be 0 to the third minus 2 times 0 squared, which is 0. And f of, what's the other guy, 4/3. Again, back into the original function. 4/3 cubed minus 2 times 4/3 squared, which gives me 64 over 27 minus, that would be 16 over 9 times 2, 32/9. Take each of those times 3 on that second fraction because again I want to combine these together. So this would be 96/27. If I subtract that, I get 32 negative over 27. And then of course I would just write my final solution. So part E, which is min or max. So I've got a max at 0, comma 0, and I have a min at negative 32, oh, just kidding, no, at 4/3, comma, negative 32/27. Again, I strongly encourage you to plug that equation back into Desmos or into your calculator and evaluate it and make sure that everything is right, especially if you're doing this for an assessment.